So welcome back, guys. So let's move on and talk about the figure size, aspect ratio and DPI. While creating figure object, Matplotlib allows the aspect ratio, DPI and figure size to be specified. Fig size is actually the width and height of the figure in inches, and DPI is dots per inch or pixels per inch. So when we create figure, say fig equal to plt dot figure, and if we shift tab we see there are lots of parameters: fig size, DPI, face color. We will talk about them later, but at the moment fig size and DPI. Let's copy these two and paste them here. We want a figure size, say 10 and 5, and we want the DPI 100. So if we run this cell, we have created an object with figure size 10, 5 and DPI 100. Let's add some cell to make some more space. So similarly, we can pass in these arguments in subplots as well. Like if we have fig axis equal to plt dot subplots, we can pass in fig size equal to, say we want 10 into 5. So let's put the data on this plot as well, axis dot plot, and let's run this code. So here we have the figure size, which is now 10 to 5 inches. We can save these figures as well. So Matplotlib provides range of options to save image as JPEG, PDF, PNG, EPS and so on. If we want to save this figure, which is fig, we can call fig.save fig, and we can pass in the name fig name, and we can pass in the extension. Let's say we want PNG, and then we can pass in the DPI as well. Let's say we want to save with 100 DPI, and if we run this thing, we have saved this image. So if we go back to the folder in which we are working, we can go and check the figure which is saved now. So let's go back and check. So here we have fig name.png. So this figure is saved in our working directory. So moving forward, decorating the figures is also very important. We have learned that we can add X labels, Y labels, and plot title using simply axis.set X label, axis.set Y label, and axis.set title. So let's see how can we add the legends on our plot. So let's create fig equal to plt dot figure, and then axis equal to fig dot add axis, and we pass in a list for, say, now we can pass in 0, 0, 1 and 1. Let's put some data on the figure. Axis dot plot, and we want x and we want x square, and here we can give label equal to as a string x square, and let's copy this one, paste again, and instead of square let's plot cube and set the label is cube, and run this cell here. So here we have x and x square and x cube. Now we want legends, we want these labels as legend here. So what we need to do, it is again very simple. We need axis and call legends. So with simple one line axis dot legend, we are going to get these x square and x cube as legends to this plot. So let's run this cell. So here we have the legends with one single axis dot legend line. So the position of the legend can be specified using an optional keyword argument LOC in a legend function. So we can pass in LOC equal to 1, and this 1 is for right corner, so we have right corner. If we pass in 2, this is for left corner, and if we pass in 3, this is for lower left corner, and if we pass in 4, this is for lower right corner. So these 4 are the commonly used locations for legend. So 1 for upper right corner, 2 for upper left corner, 3 for lower left corner, and 4 for lower right corner. We can pass in LOC equal to 0 and let Matplotlib decide the optimal location for our legend. So if we pass in 0 and see how the Matplotlib decides. So Matplotlib is deciding left upper corner for our legend location. Let's talk about color, line width, line types, marker style, and so many other options. There are lots of options available in Matplotlib to customize the plot. We will explore few of them, and we will learn more along the way to this course. So the color and other graphical elements can be defined in number of ways, like MATLAB-like syntax, where we have R in quotes for red color, and if we want a line with dot, we simply pass in R dot and hyphen and so on. Let's try with some examples here. So we will start with fig again. Axis equal to plt dot subplots, and let's put the data on axis dot plot x plus 1, and we want red line with dots. Let's copy this one, paste it here, and now instead of x plus 1, let's pass in x plus 2. We want to separate these two lines, and this is why we're setting offset here, and we pass in G double hyphen. So let's run this cell. We are expecting a red line with dots and a green dotted line. Let's run this cell. So here we have a red line with dots and a green dotted line. So moving forward, the appropriate way to use color is with color parameters. So color equal to purple, color equal to blue, and we can even pass in RGB hex codes as well. There's another optional parameter, alpha, which controls the transparency of the line or transparency of the color. Let's copy this code here and paste it here. Now what we want, let's say we pass in color equal to blue and alpha equal to 0.5, and for x plus 2 we want, say, color equal to, let's pass in the hex code for purple, and let's copy this one, paste it here, and instead of 2 let's add 3 here, and let's pass in code for yellow here. So let's run this cell. So we have blue, purple, and yellow. This alpha equal to 0.5 is setting the transparency to the half. Let's check this thing. What if we want 1? So here we are getting much lighter line because we are setting alpha equal to 0.1. What if we want 0.6 or say 0.8? So this is much darker. So alpha controls the transparency. We can pass in alpha for the other lines as well. Moving forward, we can control the line width, line style, marker style, and lots of other parameters. Let's try to explore few of them. So once again, start with fig axis equal to plt dot subplots fig size 10 8. So I'm repeating this code again and again so that you memorize and you know the syntax, how it is going to work in the future as well. So axis dot plot, put the data on, set the color equal to, say we want purple, and let's set the line width here to say 4, and line style equal to, say we want continuous line, and let's run this first. So here we have, let's fit this to the screen. So here we have, now this one, we have a line width 4, line style a continuous line with purple color. Let's pass in marker here. So here we have marker, and let's change the marker size. Let's pass in say 8 and rerun. So the marker is bigger now. Let's pass in 18 just to make it much bigger. So here we have much bigger marker now. Let's set the marker face color and say it is. Let's rerun this code. So here we have the marker face color. Let's set this line width as well, which is marker edge width. So marker edge width, let's set it to 4. So we have thicker marker edge width. We can set the color of this marker edge width as well. So we can pass in marker edge color. Let's set it to red and rerun this one. So now we have marker edge color is red. So there are lots of other options that we can play with. So moving forward, Matplotlib conveniently allows the control on the axis as well. We can set the x and y limits using setXlim and setYlim methods. We can automatically get the tight fitted axis range as well if we pass in tight to the axis AXIS. Let's try with example. So fig axis equal to plt dot subplots. Let's pass in n rows equal to 1 and n calls equal to 3, and fig size equal to 10 and say 3. We have 1 row and 3 columns, so we are going to create 3 plots here. Let's grab the first one, and we know we can grab with index. So axis at index 0 plot some data, say x and y, and axis dot set title default. So here it should be 0. Let's copy this one, paste it here, and axis 1 plot xy, axis 1 set title tight, and let's pass in axis 1 dot axis and pass in tight. Let's paste the code again and grab the index 2, plot xy and custom, because we want to set the limits now for x and y. So x2 dot set x lim, and say we want to have 1 to 4, so pass in a list with 1 to 4. And now we want to set y lim, say we want 0 to 50 here. So these are three plots. In the first one we are getting default range, in the second one we are getting tight axis, in the third one we are customizing the x and y range. So let's run this code here. So here we have, in the first one this is default, in the second one this is tight. You may not see much difference between these two at the moment. And the third one is custom, where we are setting y from 0 to 50 and x from 1 to 4. So moving forward, let's talk about some commonly used plots. It is very common to plot a scatter plot. We can create a scatter plot simply by plt dot scatter, and if we pass in data x and y, plt scatter x and y, we are going to create a scatter plot here. So moving forward, let's talk about the histogram, how we can create histogram using Matplotlib. So for this purpose we have to create data first. So let's import from random import sample. So and data equal to sample. We can use range here and pass in 1 to 1000 and 100. So what this sample is doing, sample is selecting 100 numbers from a list of 1000 numbers which are generated by range. So let's run this cell and we have data. Let's check. So we have list of numbers. Let's check its length. So here we have 100 numbers from 1 to 1000 numbers, and we are getting these numbers using sample. Let's call plt.hist now and pass in data. So here we have histogram for our data that we have generated in this code. So finally, let's talk about Boxplot now. So we need to create data again for the Boxplot. Let's create a data, and we can use np dot random dot normal and then pass in 0, std and 100, and for std in range 1 to 4. So what std is, we want spread between range from 1 to 4. So we are using list comprehension here to generate the data. So let's run this thing and see how the data look like. So here we have data. So we have 3 arrays and each array have 100 elements. So we can check the length here. So these are 3 arrays, and if we pass in 0, we can check 100 elements in 0, 100 element in 1, and 100 element in 2. So what we are doing, we are using np.random.normal from 0 up till 100 elements with standard deviation using range function in each array. Now we can use this data to plot the box plot. So we call plt.boxplot and pass in data. Let's avoid this lots of text here. So plt.show, so we can print using show. So here we have the box plot. We can pass in range of parameter, and if you want you can press shift tab to explore more. This is quite long list of parameters that we can pass in to Boxplot. You may not use all of them, but during the course we may explore more on these parameters that you can pass. So guys, this was all about Matplotlib essentials. I hope you enjoyed the lecture and got key concepts on Matplotlib essentials. There is another notebook in the course material which is in Matplotlib folder. This advanced notebook contains some other features in Matplotlib, and it is good to know, but they are not commonly used. If you want, you can explore and go through this code in the advanced notebook. You can set the custom label alpha, beta, gamma, and so on, like this one. You can set the log scale, and then you can set the scientific notations and axis number and axis label spacing and much more. If you have some extra time, just go through this advanced notebook and explore more about the available features in Matplotlib. Like we can set the spine color, and you can see how the plot is passing through origin and how to set this kind of scale and much more. So this was all about Matplotlib essentials. See you in the next lecture where we will do some exercises in Matplotlib. Good luck.